So what are we going to do today? Well, we're going to do our best to answer some key questions, and that begins with manufacturing execution systems. So what is MES? We'll talk about what is OEE, go into that background a little bit, why you should use it, and then we go into the next step of modeling the manufacturing environment and talking about the data needs. And we'll do all that as background before we start setting up the software, okay? And we're going to try to get to building a report and dashboard and things like that. All right. Well, first, the necessary background of what is MES, or manufacturing execution systems. So, MES software is a particular space. It's a particular category of software within the manufacturing IT stack. You can see a model based on the Purdue model at right here. And it's used to control, track, document, the manufacture of goods, right? And the key standard for it is ISA 95. So we've aligned our products at Sepasoft that, of course, run on the Ignition platform around this international non-proprietary standard. And a lot of industry experts put their heads together and said, okay, how are we going to organize this information for MES, or if you prefer MOM, manufacturing operations management, and that's the purpose of that standard with its models, etc. So that's that. I'd like to take a second here and talk about where MES fits in this model in the manufacturing IT stack. And I think it's very important, if you are an engineer and you are going to be implementing MES solutions, that you understand these different spaces, these different categories of systems. So you're probably familiar with the control layer or the machine layer, right? Here we're talking about PLCs, and this is something that is a category that is physically involved in the process of manufacturing materials. So directly controlling the starting and stopping, the opening and closing, all of those types of things, right? And typically we have to do that very rapidly, right? So we're talking about single digit, maybe double digit millisecond time scale. The data is pretty simple, on or off. Of course, there's examples where logic and data gets more complex at the control level, but as a general rule of thumb, we're talking about Booleans and just primitive data types and things like that, right? So very close to the physical process, extremely close, very fast, and generally simple. As we go up this pyramid into human-machine interface, or HMI, we're typically a step away from the physical equipment, but we need to control it. And so here, an operator is going to be, looking at the aggregation of multiple signals in a graphical form to make decisions. So the data is getting a little bit more complex. Maybe the rules are getting a little bit more complex around that data. And the time scale has increased. We've gone from maybe double-digit milliseconds to triple-digit milliseconds, right? So it still looks instantaneous and real-time to the user, but it's not as fast as a PLC. And we've taken that step away from the physical process. As we go up to supervisory control and data acquisition, or SCADA, we're now aggregating data from multiple equipment, multiple processes. And so, our time scale increases. Rule of thumb is around a second. And our physical distance from the physical process has increased, right? We're not immediately immersed in it like the control layer, or a step away like an HMI. Now we're looking at maybe the whole plant. And the rule sets and the data become more complex. So now we're talking about aggregating historian values and doing some calculations, doing alarming and some of those monitoring features, right? So when do we escalate this alarm? That's a more complex rule set to more complex data than we necessarily saw in the control or HMI layers. Now we get to the purpose of Sepasoft, which is MES. And for MES, we're taking that data from the plant floor, from the prior levels of control, HMI and SCADA, and we're applying yet more complex rule sets. We're organizing that data into production orders, schedules, KPIs, and genealogy information, things like that, right? So that's yet more complex data. Our time scale goes up. Typically, we're looking at around 1 minute for the time scale on MES, and we're further away from the physical process, right? We're thinking more in terms of maybe an IT model than a PLC and physical hardware-based model, right? So we're thinking about work centers and things like that. Of course, above MES and MOM, we have our enterprise resource planning or ERP systems, and this is as far as this model goes, right? We're going to take an even larger step away from the physical process. We're probably looking at multiple plants rather than a single machine. Time scale increases. Now we're talking about a shift or a day or a week, something like that, typically. And the data becomes yet more complex and the rule sets become more complex. Now we're looking at ordering information and legal information and HR information and things like that. So the data has now become very complex. The rule sets are very complex. When do these taxes apply and things like that. So very far away from simple ones and zeros, turning things on and off in a machine, right? So why am I going over this and taking a fair amount of time explaining it? Well, it's important to understand the differences between these systems so that if you're an engineer or project manager looking at your MES project or your manufacturing digitization project, that you're going to use the right tool and the right systems for the job, right? So there are some jobs that or tasks that the control layer is well suited to, some that are not. And I would say calculating OEE falls nicely into that MES layer. We're typically going to be aggregating data from multiple pieces of equipment. We need to have master material information and things like that. That's not something that you want to do at the control layer, let's say. Neither is it something you want to do at the ERP layer. So understanding the differences between these systems helps you make better decisions, more sustainable decisions around which tool you select to do the jobs that you need to do in your projects. Okay, so we talked a little bit about what is MES. Let's get into what is OEE. Obviously, overall equipment effectiveness is it's what the acronym stands for. This is a metric to give us an honest scorecard of how our equipment or processes are running. Okay, it's a very simple calculation on the face of it, right? OEE is equal to the multiplication of these three factors: OEE availability, performance, and quality. So let's get into each one. Okay, I've got an explanation over here. We don't have to go into all of that, just briefly. Availability is the ratio of time that the equipment is running against the time that it should be running. So are we doing work when we're supposed to do work, right? So that's availability in a nutshell, right? Ratio of time running to the time that should be running. Okay. And next up is OEE performance. Performance is the ratio of units attempted against the ideal number of units that should have been attempted. So availability represents. Let me go back for a second. Availability really represents the runtime and therefore gives you insight into how much downtime you have, right, with the equipment. And performance It gives you insight into, are we running at rate? So are we running at the ideal rate for this material on this piece of equipment or not? If we're anything under 100%, then we have opportunity to increase rate there. Notice that in the denominator of this expression here, actual number of units divided by standard rate times actual runtime, that it's not production time here, it's runtime. Why is that? Well, this is one of the great features of OEE, and I refer to it as the self-diagnosing nature of the metric. So we're judging rate based on the actual runtime, and we're not regarding downtime. And the reason for that is we don't want these individual factors to be dependent on one another in a way that would kind of double score or double count some kind of problem. What do I mean by that? Well, if I used production time here instead of actual runtime, then a downtime event would negatively impact my OEE performance factor as well as my OEE availability factor. Why is that important? Well, if I did that, I wouldn't be sure when I look at those scores where the nature of the problem lies. Now, because I use actual runtime here rather than production time, a downtime event does not impact my OEE performance. It doesn't affect, my rate score, if you will. It does affect my availability score. So at a glance, I can look at OEE availability, compare it to performance, and say, oh, my availability is lower than my performance. Therefore, I'm having issues with downtime occurrences. Okay, so it has a self-diagnosing nature to it because of this isolation of the OEE factors. So I think that's a huge benefit, and this is important to understand about OEE, but really important to leverage in your factory, right, in your plant. Okay, notice here that this is the actual number of units started rather than the number of units produced. Why is that? Well, we use the number of units started because we're evaluating if the equipment or process is running at rate. The number of good units that come out of the back end of the equipment would indicate not just rate, but also quality, right? So we don't, just like I explained with availability and performance, we don't want to entangle those and reduce our ability to perceive the nature of the problems. If we used output instead of input here for performance, we would do the same thing with quality. Speaking of which, let's go on to quality here. So here we have OEE quality. You can see that this is the ratio of good units produced versus the total number of units possible. If we produced all bad units, right, then we would see immediately that our OEE quality score would be 0, and we know, hey, we need to take action, on this basis, right? Okay, so I'm going to go back for a second to this one. So we just talked about these 3 factors: availability, are we running when we're supposed to be running? Performance, when we run, do we run at rate? And quality, when we're producing product, is it good product or not, right? Notice that we multiply these together. So if one of them was 0, let's say we produced all scrap. Hypothetically, of course, right? Never do that in a real factory. Everything we pump out of the machine is garbage, unfortunately. Okay, so our OEE score 0 times 100 times 100, whatever these are, OEE is going to be 0. So just a quick word on the OEE score. I know we have folks from all over the world using this product, so maybe some of my examples are localized to the US, where Sepasoft is located, but it's very common for folks to have an expectation when it comes to a score from 0 to 100, like OEE is. To say, oh, well, I'm going to expect, a high score. I want an A in school, right? And if you're on this call, you're probably an engineer. You probably did very well in school, and you're used to getting, good grades, good marks in school, right? Well, this is not like that. We can't judge this with that bias. We need to let the numbers fall where they are, and then focus on continuous improvement from there. So this gives us an honest reckoning of how well the equipment or process is performing, and then the answer is go from there. So let the numbers fall where they are. Don't get focused on, well, we're a great manufacturer, we better have a 90% plus. No, that's not how this works. And if you think about it for a second, if you had 80% or 90% times 90% times 90%, it's not going to be 90%. So anyway, just a quick word there based on what I've seen when folks begin to use OEE. Okay, so now we know what OEE is. So why do we want to use OEE? Well, first, just in general, it's better to know than to guess, especially when you have problems, right? If you can identify and understand the nature of the problem, then you can come up with a solution for it, and that's just true for all problems, rather than just throwing darts, right? And that's aided by that self-diagnosing nature of this metric. Just at a glance, you can see which what kind of problem is affecting the score and therefore impacting your effectiveness, right? One of the really nice features of OEE is the ability to compare different equipment, different materials and processes. So because of the nature of the isolation of those factors, for availability, we looked at run time divided by production time, right? So if I run one piece of equipment 24/7, that's fine. I may have to compare that to another piece of equipment that I only run 4 hours a day. Well, how can I compare those two, right? Well, this metric of OEE normalizes that and gives me an apples to apples comparison, right? Similarly, with OEE performance, you notice that in the denominator there, we had standard rate. So there is an ideal production rate for that material on that equipment. And because we're using that ideal rate, then we can understand how many units we started with that combination of material and equipment, and therefore again normalize that, get it to a percentage, and compare percent to percent, apples to apples. Okay, so we might make material or products that have wildly different costs, have different units of measure, and take different amounts of time. That's fine. We can compare effectiveness in an apples to apples way. Okay, lastly, continuous improvement is necessary to remain competitive in a global marketplace. Yeah, there's always new entrants to the market that you're in. There's always going to be challenges. So if you're standing still, you're moving backwards, right? Someone else is advancing. So continuous improvement, which OEE is a very helpful metric to drive, is really necessary. So and that goes back to that kind of concept of how do we understand that score? Do we have some bias to say, oh, we value ourselves and our activity based on the score, and we have this preconceived notion of what that number means? No, really, what the number should tell you is, compared to 6 months ago, we've intervened in our processes, we've made improvements, and now that number has improved. So we started out at 45% OEE, and that was our average over 3 to 6 months for that material and that equipment. And now we've moved up to 52%. So that's tremendous, right? And here are the things that we're doing in the next year to further improve that. To give an example that one of my customers shared with me, I bumped into her. She's a lead engineer at her facility, and they'd been using the OEE downtime module for about a year. And I'm not at liberty to share the company name, unfortunately, but they work in plastics. And I bumped into her at a conference. This was pre-COVID, obviously. And I asked her, hey, it's been a while, we haven't spoken. How are things going? And she said, well, we've gone from fulfilling our orders by running 24/7 to fulfilling the same kind of quantity of orders 24/5. So we've reduced our working hours by 2 days per week because of the efficiency gains of working that continuous improvement process. And so, of course, I'm going to cheer that on. And as much as I would like to take credit for it because they were using this tool, really it's obvious. They worked their continuous improvement process. They used the data that the module provided. They used the awareness that Ignition provides, with alarms and things like that, to implement their improved processes. But really, that's all hats off to them, right? They did the work. And so what's 2 days a week worth to an organization as far as when you count labor, utilities, scrap, and intangibles like happiness of employees? People don't have to work weekends anymore. How much is that worth to an organization? I bet if we talk to HR, their turnover probably went down, and so then their training costs went down. So I think these types of things bring kind of like a health to the organization that really is far-reaching. It's not just a few bottom line dollars and cents items. There's really a lot here. Okay, so for our example here today, of course, we're leveraging the Ignition platform. This OEE downtime product installs on the Ignition platform. And whenever we're talking about Ignition in the MES context, we're talking about at least a single Ignition server and a SQL database, okay? They don't have to be on the same box. In this example, they are on the same box. Typically in a production environment, you're going to have them on separate installs, whether that's in a virtualized environment, containerized environment, or on iron. And typically they're going to be on-prem, but the on-prem, off-prem debate rages on, and it's based on what you're using the software for, right? So if you need this to effectively run your operations, and if that connectivity is interrupted, you can't, well, on-prem is the obvious answer. If, however, you're using this more for analysis and not necessarily production control, then yeah, by all means, utilize it in a public or private cloud. Okay, our source for plant floor data is Ignition and a lot of the great built-in tools there, OPC server and QTT modules, things like that. Okay, so the manufacturing data that drives OEE, where do we get it? Like I mentioned, we're going to leverage a lot of those great capabilities in Ignition. And I like this graphic. You can see we have a combination of automated data from things like PLCs, smart sensors, IoT options, of course. We can also bring in data from manual entry, and we can talk about that. And maybe databases as well. Of course, all of the modules config and real-time data that it records are stored in a SQL database. That's why on the previous slide we had that Ignition server database pair, right? Okay, so we've got those sources of data coming in. Of course, we have configuration, sources of truth, right? They might be manual, they might be downloaded from an ERP. Of course, we have our ERP connectivity suite with the Sepasoft Business Connector. That's outside of the scope of this webinar, but of course, as you'd guess, I'm happy to chat about that. And we've got some resources on the website for that. Okay, of course, we can bring in data from other systems, whether that's MQTT and IIoT related, or through Business Connector, et cetera. Maybe we need to talk to our existing CMMS. Maybe we need to talk to some other level 2, 3, 4 system. All of those are on the table. And then what do we produce? We produce operator screens for them to see necessary information, to interact with the data, add data, scheduling, outputs, dashboards, and reports. Especially when we're talking about a continuous improvement environment, so much of that is contingent on the right people getting the data in front of them, right? You can't make data-driven decisions without the data, so let's get the data in front of the people that need to use it. Okay, so what do we need as far as manufacturing data to empower this this module and this kind of mini ecosystem? Well, four things to start with. First, we need our hierarchy of equipment. So as I mentioned earlier, the key standard and the informational models that we are based on, the OEE downtime module is based on, is ISA 95. And the central reference system within those models is the equipment hierarchy. So, what factory are we at? What area within the factory? What line are we at? What station or cell, are we getting counts from? That sort of thing. So we'll talk about that in greater detail. Of course, for OEE, I mentioned performance. We have the number of units started. I mentioned quality, the number of good units. We need our production counts, in-feed, out-feed waste, and we'll talk about that as well. And then we need local status, the equipment state. As I mentioned with the OEE availability, when we're looking at the run time versus the planned production time, then equipment state tells us if we're running or if we're down or something like that. So the difference between, yes, the equipment's up and running, or no, the equipment has an e-stop pressed and so we are not running, that's pretty critical, and of course drives that OEE availability score. Lastly, in this list of necessary kind of minimum data requirements is the start and stop signals for our production activity. Now, the OEE downtime module records data 24/7. So regardless of whether or not you've started or stopped a production run, we're just going to be recording the data available, right? But we want to put that in proper context for a given production run. Hey, I'm making product A on line 1 right now. Okay, now I'm done and I'm switching over to product B, right? So those types of signals, that could be an operator button press, that could be automatically from a schedule that's downloaded from the ERP, maybe based on a PLC tag. There's some flag in the PLC that goes true, telling us, hey, we're running now, or we should be running, based on the actions that have taken place on the plant floor. I don't know what those are for you and your organization. You've got to identify those. All right, so that's what we need. We need to model the equipment. We need to capture production counts, equipment status or state, and start and stop signals. Okay, how do we get started? Well, like I said, first, the equipment modeling, and that's really outlined in the user docs. Then we look at those data needs for counts, status, and start-stop signals. At this point, we also need to start with the end in mind, right? We need to think, okay, what are the necessary outputs? What data do I need to deliver to my customers, internal or external, right? So is there a dashboard that I need to put up? Is there a report that I need to furnish at the end of the shift or the day or the week or what have you? So those things are in mind. Okay, so for modeling equipment, we've got some key questions here. And by the way, if you're like writing down feverishly what's on the screen, you don't have to do that. Our follow-up email will get you this slideshow, and you'll also have access to this recording. So if you've been taking notes, my apologies for not mentioning that earlier. Shame on me for that. Okay. So modeling the equipment, the fundamental unit of production in this equipment model is the line, and that can be tricky because everybody calls things lines, and what does that actually mean? Um, you might say, oh yeah, that's line one, or the prime line or something like that, and that's because it's called a line because the capital improvement project, when it was installed, all happened at the same time, right? But it's really made up of a number of different pieces of equipment that work independently, and you know, they don't really constitute a line as far as ISA 95 conceives of them, right? So um, sometimes I get into discussions with folks, and they're like, "Oh, this is what we call a line." And it's like, okay, that's fine, but that's why I make a lot of noise about ISA 95. I mean, this is a standard to organize this information, and that's what the software is based on, is that standard. So to help us get there, here's some questions. So first, we start with how the equipment is modeled today. How is it conceived of today within the organization? Again, that might be influenced by things that are kind of arbitrary, like the capital improvement budget and things like that, right? So we don't want to take that as fixed and final. Okay. Next, we want to ask how the equipment is tasked. Is it scheduled? Is it a manual start stop? And how does that relate to the equipment around it? Um, the example that I gave a moment ago, let's say we call this a line and we have 5 CNC machines under that line, but each CNC does its own thing, right? They're not performing some action on a part and then sending it on to the next CNC. This one, the first one is running a job for the next 12 hours. It's really complex, task, and then it's working on a given product. The next CNC machine has a completely different tasking, and there's 15 different products that it's going to pump out during that the time that the first CNC is running just one. So are those really part of the same line? Maybe in the common speech in that plant they are, but as far as 95 is concerned in the equipment model, they're really not. They're individual lines. So we need to ask, how does the equipment handle material? Again, is it passed one to the next? Are they processing material in parallel? I have a fruit processing and packaging customer that they're pitting fruit. Well, you've got to take the seeds out, right? And they have banks of equipment that are doing the same job, like 5 or 10 of these pitters in side by side, right? So they're not passing one to the next, but they are working in parallel and are considered together a line, and that's appropriate, right? So you need to think about how the material is handled. We also need to think about downtime for the equipment. So for individual machines or station cells, that's pretty easy, right? We're going to talk to the PLC ideally and get a status signal in real time saying, yeah, we're up and running, or no, we're down, we're stopped. I've got a drive fault, or safety curtain was broken, or whatever it is, right? So that's simple enough. But what about when we do have a series of machines that function together as a line? We think the kind of canonical case is the packaging line, right? So that's going to require some effort to determine what takes the line down and when the line is running. So we have in the product 5 different downtime detection algorithms that you can pick which one is appropriate to your equipment arrangement for the line, but that's something to think about. How do we assess downtime? What data do we have coming in? that's going to influence what you call a line. And then how do I even connect to this piece of equipment? How do I get those status signals and things like that? So we can't just take that for granted. Maybe some of them are manual. Okay, well, manual is good in that it's typically cheap, at least initially, right? Manual data is kind of difficult because um, now we're asking somebody to type something in. Well, that takes them away from other value add activity. So there is a cost. Oh, I thought it was cheap. You just said it was cheap, Mark. Well, yeah, nothing's free here. So also, manual data is more error prone, right? Did they type it in at exactly the moment that it happened? Did they end the downtime event exactly when it came back up? Ooh, did they attribute it correctly? Or did they deflect blame? You know, maybe they didn't set something up right, and so they said it was a different downtime reason. Now our maintenance team is going to be chasing ghosts. Well, that's no good. Sorry to throw the operations folks under the bus. But if you've worked in enough plants, you've at least seen one example like that. Hopefully it's not too frequent. Okay, so we need to think about how we get data. You know, is it manual? Is it automatic? That could influence where we draw the lines. Oh, that's a terrible pun. Well, okay, and then what data display and reporting requirements do we have for the equipment? That's going to also influence our decision. So if the plant needs to see a certain combination of equipment reported in a certain way or scheduled in a certain way, things like that, you know, we need to think about that. All right, so unfortunately, this is not a cookie cutter one size fits all solution. This really takes experience, and as we all know, experience is what you get right after you need it. So if you're starting out on your project and you're not sure what to do in modeling your equipment, give us a call. That can be an email to support@sepasoft.com and say, hey, I'd like to schedule a call with you guys to lay out my lines, right? Or review the layout that I set up. We're happy to do that. All right, so we talked about the equipment setup. Now we get into the system setup. And this is pretty standard. If you've gone through any ignition training or done any ignition projects, this should be old hat for you. If you haven't, if you're looking at some of these things and you're like, oh, I don't know how to do that, or what's ignition, then let's call time and you need to take a look at inductiveuniversity.com. Okay, and in the follow-up email we'll have a link for it, but inductiveuniversity.com is the video training website for ignition, and most of you are probably very familiar with it. You've gone through it, but our training materials and our products assume you already know your way around the ignition platform. So if me mentioning any of this, you go, oh, what's that? That's a red flag to you. Hey, I've got to do some pre-work on understanding that aspect of ignition and that aspect of setup. Okay, so installing ignition, that's a pretty simple process. Of course, installing a database, typically that's managed by IT, but simple enough. We do have some examples with MySQL at this link. So when you get this slideshow and you're setting up a DB on your local system, you can check those out. Is it the exhaustive guide to DBA? No, of course not. It's just to get you started. Want to connect to the database, this is something to keep an eye on. This is a very database intensive application, so we want to make sure that we have a database close by. We're not introducing latency there. And then we need to connect to the PLC and data sources such as OPC UA and MQTT. I'm not going to go into that here in this webinar, and we don't really go into that in our online training class. That's really in the ignition domain. So check out their resources for that, but that is usually pretty straightforward. Okay, then we install the Sepasoft modules. I'm not going to do that live here. I've already installed them, but we'll take a look at the modules page. Again, if you don't know how to do that, Inductive University. We will talk about the configuration of the Sepasoft modules, and I'll go through those steps. And then we start configuring, equipment, configuring screens, building reports, and things like that. Okay, so I grabbed a startup project. We'll have links in the follow-up email to this webinar, so you can grab that. We need to build some equipment, set up our tags. This is our source of data, and determine start-stop production run criteria. And we'll build an example dashboard and access the report library to get going with that. All right, so congratulations, you survived 40 minutes of the slide deck. Let's go over here to this system and get into get our hands dirty in Ignition. Okay, so a couple things. First, I just installed Ignition. You can see the downloads that happened earlier today. I installed Ignition from scratch. Because of some licensing things, they're no longer including the MySQL connector, jar file. So they've got instructions on how to download that. Why am I using MySQL? It performs all right, and it's pretty cheap and easy to access, right? If you use something else, we support 4 database vendors: MySQL, Microsoft SQL, Oracle, and Postgres. If you use something other than that, then that's fine, but we don't necessarily support it. So you're kind of it might be the Wild West there. So consider why you're doing that if you have to do that. Okay, and you can see I downloaded some modules. We'll go over that and this little tutorial project as a way of getting started. All right. I installed Ignition on Iron, and I also installed my database on Iron. So let me go ahead, just like, if you just downloaded 8.1.5 today and installed it, this is what it looks like, right? I'm running it on a trial, nothing fancy here. Okay, so let's go into config. The first thing is the modules. We need to install the modules. Just like all of the standard Ignition modules, we go to this page and install the modules. Let's have a quick word about these modules. We're interested in OEE downtime, and we also have this production module. So the production module is a kind of repository of common libraries that our modules use. So anytime you're using OEE, you also need to install the production module. Where do I get these? Well, the place I like to get them is, here, let me go to sepasoft.com, and I mouse over the products page and go to downloads. Now, some of you might say, why are you spending time on this? Because I talk to my tech support department and I hear from them that some folks have trouble finding this. So anyway, sepasoft.com, products, downloads, and then you'll notice that we have these tabs here to support the different versions of Ignition that you are using. Notice we're still supporting Ignition 7.9, 8.0, and 8.1. Okay, now if I scroll down a little bit, I have MES Platform 3 full release. Okay, this release candidate here has our perspective components in it. We don't have full support for perspective for like our configuration components and all of our modules. So I'm not showing that today. I'm still working in Vision, okay? As the year goes on, we're releasing more and more components. You can see this table here shows you which components have been released and what we're supporting thus far, okay? So I'm gonna go to full release, and right here, OEE downtime, you can see 3.8.1 SP3. I'm gonna download that by clicking there, and same thing with the production module. Okay, what's this alphabet soup of a version number mean? Well, the first character indicates the major version number for Sepasoft. So the 3.0 modules are our latest and greatest and incorporate our enterprise features. So we want to use those. The second 2 characters indicate the Ignition compatibility. In this case, Ignition 8.1 is the major version of Ignition that this runs on. If I went over to one of these other tabs, then we'd see 3.80, 3.79, okay? And maybe you're on an existing implementation of 7.9, you haven't upgraded to 8 yet, that's fine. You can still utilize this there. The fourth character is a minor release number. And then we've got some additional characters to tell us about this build. In this case, this is Service Pack 3. So you can utilize that. And we release service packs periodically. Let's see, we started a new kind of release mechanism this year, where we're releasing a maintenance build at the end of every month. So last business day of each month, we've got like a bug fix build that goes out. So a little bit more predictable for you. And if you have questions about, hey, what's in this build, you can go to the release notes down here. Okay, one last thing about version numbers, they have to match. If you're using OEE downtime, you need production module, and these need to match. Okay, so don't mix and match some legacy build or something like that. All right, so we've installed these guys. Looks like our MES settings nav panel title, the menu title didn't render correctly. That happens sometimes in Ignition. Oh well. Under MES modules, oh wait, I'm getting ahead of myself, guys. Why'd you let me do that? Okay, before I go to these settings here, let me go over here to database connections. So we've installed the modules. We need a database connection first, okay? So here you can see I have a MySQL connection, and I called it MES. You can call it really whatever you like, but I like to call it MES. And here's where I would recommend, being careful about your database connections and segregating them. The MES modules are very database intensive, tools. So we don't want to share that connection like with the tag historian, for instance, or the SQL Bridge module, or something else that is going to utilize that connection. So get a dedicated connection. If I was using, this was a production system, then I would have database connections to, for tag historian, for custom tables or whatever, right? Okay, so that's installing the modules and setting up database connections. Now I'm going to go down here to this guy, and I have my MES module settings. So we need to tell the module a few things before we get going. The first is the user source profile. So for MES, security purposes and user credentials, what are we going to use? Of course, you could have different user source profiles. In this case, I'm just going to use the default, but we have to tell it that to start with. And you can see that it synchronizes those users automatically every hour. Of course, you can change that. The next thing we need to do is select our data source, the database that we want the modules to use. Like I mentioned, you're probably going to have multiple database connections on your Ignition server. So tell the module which one to use. This runtime database and analysis database distinction is a bit of a legacy support item for us, for backwards compatibility. I would recommend that you set them to be the same, okay? So you can see I only have one there, so it just picks it as a matter of course. For MES, normally you're going to have multiple. Make sure you pick the same one, and it's dedicated for MES use. Okay, there's other features here that I'm not going to get into. One thing to note here is this MES Gateway Configuration Project. This is where project-specific resources live for MES. If you wanted to use a different project for that purpose, you can, but the MES Gateway project is created automatically by the modules when you install them. So that's that. Now I'm going to go ahead and save those changes, and we've got those there. Okay, great. Well, that's interesting that it's doing that. Oh well. Okay, next up is the enterprise settings. What are the enterprise settings? Well, like I mentioned, the 3.0 modules include our enterprise feature set and give us capabilities to connect multiple servers in an enterprise hierarchy and share data across that and do a lot of cool stuff. Anyway, we're not really using that in this example. This is a single server kind of standalone example just to get you started. So I'm basically just going to leave all this alone. But if you're in a multi-server hierarchy, then this is where you tell it, hey, here's your parent within the hierarchy, or maybe you are the top of the heap, right? Maybe you're the root, and everything else is underneath you. Now, this presupposes that you've already set up your gateway network connections. So that needs to happen first, but that's all beyond the scope of this webinar. All right, once again, save. All right, so that does it for config, setting up the modules, kind of telling the modules where they are, where they save data, things like that. Okay. Next up, you need to hit your designer launcher, right? And launch your designer. Okay. Now, in this case, let's go here to the Sepasoft website to help get you started, and I'll export this this project so you don't have to actually do this, but I want you to see where this is at. I went to the Learn tab, and there's some really helpful resources here for you, okay? Obviously, we've got the user manual that goes through all of the components and the objects and things like that. And we've got, I think, about 200 plus training videos here showing you how to do things. And here in the online tutorial, we actually go through step by step, with OEE. And an open secret is that on the review page, I have a download link for the completed project. So I downloaded that and installed it here in the MES Gateway project. And so now I can leverage that. They're not fancy. They're pretty bare just to get the get the functionality in front of you and get you going. Okay. So like I mentioned, we need to set up our equipment model first. So let me go, well, first let me explain what it is we're looking at. This is the equipment manager. Let me go over here to the component palette. And you can find this guy in the production section. Let me go down here, MES equipment manager. There you go. All right. Do I need both of them? Yeah. Okay. So I'll put this in a preview mode. Now notice our equipment hierarchy starts with the enterprise level, and then underneath that, we can set up our sites. These are individual factories, and build out this hierarchy. Now, a quick word, as I'm setting this up really rapidly here. In a production setting, I wouldn't just rush in like this, okay? Naming conventions, things like that are rather important, so pick a naming convention, stick to it. If you're gonna use spaces, capitalization, underscores, whatever, figure that out and run with it. Okay, but what you don't wanna do is you don't wanna have 3 different naming conventions in conflict, and then you don't know, what's what. Okay, so here, just really quickly, I created site 1, area 1, and line 1. And presumably I've gone through and I've looked at that list of questions that we discussed on the slide for modeling equipment. So, how is this equipment tasked? How does it handle material? What kind of reporting requirements does it have? So on and so forth, right? So that homework needs to be done before you're doing this in the product, okay? If you don't, welcome to duplicating work, and ask me how I know. I'm a former systems integrator. I've done this in the field. I've made these mistakes for myself. So I'm telling you, please pursue it this way, and so that you don't have to repeat the mistakes that I made, okay? All right, now notice that after I created this line, all of these items are red. They are not active as of yet, so you can activate them by right-clicking here, and we've got this helpful pop-up. Do you want to activate the children as well? Yes, and that applies, licensing to them. So what I wouldn't recommend is kind of horsing around with this activate, deactivate, where you're trying to, run reports on a deactivated line and things like that. You know, get in or out of the pool there, okay? Typically, it's a temporary thing that those equipment items are deactivated, and that's during initial setup, right? Okay, so I have the world's simplest line. Of course, I could have, a more complex line, right? Based on how, here, let's go line 2. And underneath it, maybe I have a cell 1, cell 2, and so forth, right? Let's do cell 3 as well. We're probably going to run out of time, so I'm not going to go crazy with this. And of course, we can also add cell groups. So maybe there's a, I'll go CG1, and I'm probably breaking my naming convention. Do as I say, not as I do, everyone, okay? So here, maybe there's a subline. Let's say we're in a packaging context, right? And here at the end, I have a pair of palletizers or something like that, right? And they do the same job, and I want to show them in parallel. I could model that within the cell group. And actually, on our user manual, we have examples of very complex line structures with nested cell groups within cell groups. You can go to n levels here. And yeah, so that's up to you. Whenever you can, when you're in this modeling process, consider what is the simplest model that can accomplish my goals. I've seen folks introduce complexity seemingly for complexity's sake, and I don't recommend that. So there's some challenges that can be introduced as a result. So whenever you can, try to go with the simplest model for your equipment. And again, if you have questions about, hey, how do I do this? Or I took a stab at it, it's my first time, let's review it together. Again, give us a call, support@sepasoft.com. We're happy to take some time and take a look at that and talk through the pros and cons of different modeling approaches, okay? Well, here, I'm going to stick with my absurdly simple line 1. And the next thing that I need to do is bring in relevant data. Now, in this example, I don't have a PLC to connect to, so I'm going to just, fudge it over here. And we'll get to that in a second. But as you can see in the equipment manager, we can set up our counters. And by default, every piece of equipment has this material out counter created. So we can hook up the tags in the ignition tag server that have the production count information, in feed, out, feed, waste, to our piece of equipment. We can also set up tag collectors. So if we want to drive any of this type of data from tags in the PLC, we can do that. And we'll talk about the default case for that. We can also assign a shift to the piece of equipment. So, what shifts are built in the system, and which ones apply to this piece of equipment. And we can also bring in additional factors, and we're going to do that here in just a second. Okay, so to kind of represent our data here, I'm going to go ahead and build a tag structure. I'm going to say new enterprise. And underneath here, new tag, new folder, I'm going to replicate the same hierarchy as we have in our equipment hierarchy. Why am I doing that? Well, as I mentioned earlier, the fundamental frame of reference in our software is the equipment hierarchy. So if we have the same structure new enterprise, site 1, area 1, line 1, I have a unique address to that piece of equipment within the MES product. And if I use the same hierarchy over here, that address, that unique address, new enterprise, site 1, area 1, line 1, also corresponds to my raw data sources. So with that unique address for line 1, I can access raw data from SCADA, and control layers, and then also co-locate that data with MES. Okay, so that's a key best practice that you'll want to observe. Okay, I'm going to create some tags, new standard tags, and I'm just going to do memory tags here. Why am I doing that? Like I said, I don't have a PLC connected. So here I've got state. This is going to be an integer. Just going to say 1 there. Okay. And so I'm creating the data tags in this folder. For you, presumably you're going to be, bringing over some tags from the PLC. Okay. So here, instead of state, now I'm going to have infeed and outfeed and waste. Okay, and I'm going to add one more, and this one's going to be a little bit different. Still a memory tag. This is going to be operator, and it's going to be a string, and it's user McUserson. Very common name, I'm sure. Obviously, just a stand-in string there for us. Okay, so here's the raw data that I'm working with. Our 4 kind of standard data points that kind of our minimum requirement. Their infeed, outfeed, waste, our production counts, and the equipment state. That's that local status value telling us if the equipment's running or down. Okay, so let's go over to counters, and for my material out, I'm going to point to that tag. So here, new enterprise, site 1, area 1, line 1, and this is material out, so that's outfeed. Okay, so that's simple. I can also use equipment path parameterization, equipment path in curly braces / outfeed. Why am I doing that? Well, like I said, I'm using that same structure as the equipment hierarchy, and that can save me some time. All right, I'm going to do the same thing for the material in. And I need to make sure I tell it that this is infeed, and I have 3 different methods of processing the raw counter values coming in. I'm not going to go into detail here. That's the kind of thing that we do in our paid training, and of course we explain it fully in the online documentation. All right. And then lastly, I have the waste counter. All right, reject and equipment path waste. All right. Okay, so I have my production counters, infeed, outfeed, waste, and I have those tied to the raw data coming in through the Ignition tag server, presumably from the PLCs, right? Now, if you've been using Ignition for any length of time, you know that these tags over here, like I just set them up as static data points, can be populated really from wherever you like. So let's say they could be an expression, right? Combining multiple values. They could be from a PLC. They could be from a SQL database. Or of course, like in this example, populated from a user through the screen. So what you do there is up to you and based on your use case. So very flexible on the data ingestion mechanisms there. Further, although I only set up one input, output, and waste counter value here, or counters, we might have multiple infeed lanes at a piece of equipment that we wish to track individually. That's fine. You can create as many of these counters as you like. Just make sure that the kind is correct, okay? So if you have 5 different infeeds, exit without saving, yes. If you've got 5 different infeeds and you want to track those, that's fine. If you have 3 different reject mechanisms, and you want to individually identify them, that's great. The module will keep track of the individual counters and aggregate them for the purpose of OEE calculation. All right, so I'll save those. Now we have 3 defined counters. Next up, I'm going to go to tag collectors, and I need to find my way to state. State is that local status that tells us, if the equipment's running or down. Again, I'm going to use my equipment path parameterization and say equipment path/state. Now, this is the default use case for tag collectors. Just one tag, and that being the state tag. Okay. So usually, the default scenario, I've got my production counters and I've got my state tag. That's it. Can you fill in the rest of these? Yes, that's a little bit more of an advanced use case. There are times when that's more appropriate. That's the kind of thing that we talk about in the training class. But as soon as you start populating the rest of these with tags, you are driving things. You are taking control. And the normal kind of life cycle for these values that is built into the OEE downtime module is bypassed, and we take your value. So if you want that, you want the module to function in more of a passive listening type mode, that's completely appropriate. But know that you're in the driver's seat, so it's going to be what you tell it. And of course, that's a problem with computers, right? They don't. Well, fortunately, they don't read minds yet, but they do exactly what we tell them to do. And sometimes we don't tell them exactly what we want. And so then we can have problems. If you think you have a use case where you have to go about it that way, again, feel free to reach out to us. Let's get a design consultation call going. And this is every day for us, right? So we're happy to have a chat and talk through what that might look like. Okay, so we've set up our kind of bare minimum for raw data collection at a piece of equipment. The counters to calculate OEE and the state to calculate OEE with availability. All right, and that of course feeds into downtime analysis as well. All right, now notice I did set up, let's see here, 5. I was told there would be no math, tags. So let's take a look at operator here. What am I doing there? Well, there's going to be event-driven data that is going to have a bearing on your downtime, your OEE, your production counts, things like that. And operator is a very common one, right? Maybe tooling, maybe some environmental factors, maybe supplier information also needs to be brought to bear. And you want to get not just OEE, not just production counts or downtime, but an awareness of how these other factors can affect those things. How do we handle that? Well, that's where additional factors, like their name suggests, comes in. I click on additional factors for line 1, and I can create these data items, these additional factors that get recorded within the system and then can be exposed into analysis and used in dashboarding and things like that. So here, I'm going to create a new additional factor called operator. And yes, you guessed it, I'm going to utilize my equipment path parameterization. Oh, it would help if I spelled it right. What did I say earlier about naming conventions and sticking to it? Okay, so equipment path / operator, okay? And that's going to point to this guy right here. So now on change, we're going to record this value. And then later, if I want to access OEE based on operator or production counts or something like that, I can see that data. Okay, so that's the default is just counters and tag collectors. Typically, you're going to want to select some additional factors for additional usefulness in analysis. Okay. Next up is shift. In this case, I'll just select the example. Always an example are built-in shifts within Ignition. Let's take a second and talk about shift. So over here, I have a shift management screen. For those of you that have been using Ignition for a long time, you'll recognize that this is a built-in Ignition component and feature set. So here, if I come over here and say, shift 1, and maybe it's weekdays and it's midnight to 11 a.m., which is kind of arbitrary. I've now created shift 1. If I come back over here and go to shifts, you can see I have shift 1 available for selection. Okay, so so if I want to do analysis on the basis of the current shift and things like that, I can do so. Okay. Boy, there's so much to cover and so little time. Okay, real quick, downtime detection methods. I'm not going to go deep on this. This is where it's selected for your piece of equipment. For our standalone line, we're using equipment state. That just means we're going to use the tag. For the other ones, those involve aggregation for multiple pieces of equipment underneath the line, and those are explained in our user manual. We also have video on that, and we go through it thoroughly in our training class. Okay, as far as the status signal here, you notice I set up state as 1. That doesn't say e-stop, that's a 1. How do we get from a 1 to e-stop, right? Well, that is this equipment state class. Okay, so equipment states represent the possible statuses for the equipment, and they're organized in these equipment state classes. You can think of them as mappings, right? So this default mapping is applied to line 1. And so here, let me mouse over this guy. When I get a 3 for my state, then I know an unplanned downtime event is active on that piece of equipment. And looks like running is code 1. So if I get a value of 1, I know that it's running right now. Let's go ahead and add a new one real quick. And I'll say e-stop. It's going to be code 7. It's of type unplanned downtime. These are, of course, hard-coded types that are built in and cannot be changed. I'm not going to go into all the details here. We just don't have time. Okay, so there I've got e-stop. And so now if I get a 7 for my state, then I know, hey, we've got an e-stop. All right, let's go to our analysis screen and take a quick look at the raw data. So I set up the configuration of the data, how the data comes into the module, and here we have a tool called the MES value editor, and it gives us a view into the raw data in the database. This is the key data validation and troubleshooting step for raw information. This is where I can determine if the raw value came into the system or not. So here, let me scroll down here and look at equipment state, and I'm looking at line 1. Is this working here? Well, guys, we're doing it live. So that shows me that this is not working here. Let's take a look. Are we looking at line 1? We are. And that looks like an acceptable date range. So why is that not working how I expect? Oh, did this save fail? Did I hit back instead of save? Huh. Well, okay, hit enter, hit save. Okay, let's trigger that, 7. Let's go back over here and select what collector type. I want equipment state. Okay, there we go. And it looks like I didn't have the path in there. It wasn't captured properly. And then once I hit enter and then save, it looks like it worked. And now it's picking it up just fine. Okay, well, like I said, this is a really important tool to make sure your data validation is established, right? That the raw data that you think is coming into the system is actually being captured by the system. Okay, let's go take a look at our counters. So I'm going to go back up to the top, equipment count, and then I have these items here. This is not looking good because I don't have anything here. Let's look at 2 here. Do I have anything? Oh, there it is. Good. Okay. 3. And these are set to update on the minute. So I would expect that to update on the minute here. Of course, when you're looking at it, a watched pot doesn't boil. Go back to material out. No, I don't have that. That's interesting. Not sure what's going on there. Well, I'm going to go back and do the same thing here for counters and look at material in. Do I have the path? I do have the path. Interesting. So our store rate is 60 seconds. We should see that every 60 seconds unless I'm having some issue with my system here. Material in. Okay, so that did come out. Okay, and this material out came through, and that is within 1 minute of each other. So I wonder if I was just impatient there with the 3 value that I typed in for outfeed. Now, you may say, well, I don't want to miss that count, to which I would say, well, you have to decide how many database records you want. In this case, the value of 60 seconds for the store rate, capturing counter values every minute is kind of an aggregation there, right? So what's appropriate to your use case? Millions of database records, perhaps, perhaps not. So that's that. Sorry, I got a little worked up there. Okay, here before we go to production control, we've got one more configuration item that we need to take care of. So we set up how data is associated with line 1 and talked a little bit about downtime and things like that. Next up is our material config. And this is using our material manager component. This is in the OEE section of the component palette, OEE material manager. And here's where we can create our materials. So I'm going to say, let's say wines. Sepasoft's located in Northern California, so seems appropriate. And then here I'll have red wines. And I have these categories of materials, and here I'll say Cabernet, and I'll apply it to line 1. So I can say, we make this product on this line. Now I'm not going to go through the production settings, but here's where we have the particulars for that material equipment relationship, okay? Of note is the standard rate. How many units per, units of product per unit time is the ideal production rate here. By default, it's 100 units per hour. Of course, we could change that per minute and change that value to be whatever we want. But that's going to be what our OEE performance calculation is based upon. All right, so I'll hit save, and now we can make CabSav on line 1, okay? Here, just real quick to kind of build out the example a little bit more. I'll say white wines, and what's a white wine? Who planned this? I think this is a white wine. We're just going to go with it, and you guys can ping me in the questions here on the webinar if these are wrong. Okay. Anyway, so we've got examples of end products that we're making, and we have them organized in these folders or material classes, and so we can apply logic based on that. I'm not going to go very far in that, but here, let's go over here to our production control screen. So we have our materials configured, we have them assigned to the equipment that can produce them, and now we can actually do that, okay? So let's go to line 1 and go ahead and say, hey, I'm going to be making Cabernet, right? And so I started that. This is the run director component, which is on the production control screen from the from the example. And now you can see that we're in changeover. I'm going to go ahead and end that changeover and begin production. So this is taking a little bit. That might be because of my computer running slow here. Oh, nice. Well, you know, we're doing it live. That's interesting that we would have that. My goodness. And I am behind about 5 minutes here, guys. Well, actually, probably closer to 10. So interesting. We're having that issue. Not sure what's going on there with that. Real quick, on this production control screen, you can see we have a time chart, the run director for manual start stop, and the downtime table. Not gonna you know, get into all of these too much. We do have videos outlining their use that I'll make sure that we get links to those in the follow-up email. Okay, here. I think at this point, I'm gonna go straight into analysis just for like 2 minutes to give you an awareness of this because we're rapidly running out of time. Okay, so on this screen, I have the analysis selector component. Now, this is one of 5 ways to access analysis data in our product. Okay, so this is maybe the engineering tool of choice. It's not necessarily the end user tool of choice. So whether you access analysis data via script, via an analysis controller, which is kind of the sister component to this one that is invisible at runtime, or you're building a report with this data, or you want live tags populated with analysis results. You know, there's all 5 of those ways, but this is a pretty handy one to get started. So I'm going to create an analysis call called test. Save that. And here I can pick and choose the data points that I wish to see. Now, there's all kinds of stuff here. Obviously, additional factors that we set up, those event-driven custom data items can be selected. Raw counters can be selected. Cycle time metrics picked, mean time between failure, asset utilization, the logistical status here, which is what equipment mode is, and of course, you know, line downtime and things like that. You know, we can go on for a couple hours about each one of these data points, right? But we're not going to. So here, real quick, I'll just find the state. Let's see, state name and the duration, and we're also looking at operator. Okay, but you can see we go into OEE, the factors, and the counters and timers that make up those factors and the calculations. So you can get at the data that you want. Pick it for yourself. And let's see here. Let's rearrange this a little bit. I'll put operator first, and then equipment name, equipment state name, and then the duration. So let's go ahead and filter this. I'm going to create a custom filter expression. And whenever you're doing that, you start with equipment path. I'm going to say, hey, line 1. Okay. And then do some grouping. I'm going to get a unique row for each operator and a unique row for each state name. And let's order it by state duration. Okay, so here we've got, for the majority of history, we've been disabled, right, for the equipment, and unplanned downtime, 6.68 there, and running. Let's see here. Let's go ahead and reduce this and rerun it. All right. Anyway, the point being, I can get to the data that I want to see, the calculated data, as opposed to the raw data, right? So over here in the value editor, we're looking at raw data. Over here in the analysis selector, we're looking at calculated data. We can get to that data, access that data, and save that call to the analysis, right here and very easily, and then begin to drive our dashboards and reports with that. Just really quickly, my gosh, we're out of time. I'm gonna go over here to our reports, and I do have this example report for you that goes through, and it's not gonna have much in the way of data, but we have several different pages, 9 different pages of example reports. So OEE by shift. It's interesting when you import this, it resizes that. It keeps doing that to me. Anyway, you can see downtime by equipment, by reason, downtime in a stacked bar chart example. So is it everything that you need for your reporting? No, but it gets you started and gets you thinking, okay, this is how I can do this, okay? So line production counts by shift, and by shift by product. So examples of how to do common production reporting type activity, asset utilization at the line level. So this is also included in that project. So I think that will accelerate you as well. Okay, well guys, I'm sorry that that was a little rocky there at the end. We didn't really get into dashboarding too much. We just barely scratched the surface on analysis. Did look at the report library example that you can use and kind of make your own. All right. So with the waning moments of this call, let's transition over to some Q&A. So here, where's my questions? Okay, first off, when is the next training class? Okay, let me go back over here and bring this up. So as I mentioned, the next training class is next week. In fact, if you go to classroom training under the Learn tab, that's our proctored training classes. We use our online tutorial and we walk through that step by step. It's actually sold out. Did I say next week? No. Oh yeah, it is next week. Okay, 11th to the 13th. If you're on a tight project timeline, you think, hey, I need to get into that class, reach out to us. We might be able to squeeze 1 or 2 more in. Okay, these are run online, and we set up Amazon workspaces for everybody in the course. And what we do is we go through the online training material, but we talk through the design decisions that you have to make at each point, and do our best to field any questions live. And so we all go through click for click through the training tutorial. And again, I think the key value add is discussing the design decisions, why you would use one approach versus another there. So anyway, if that's something that you think you need for your project, please reach out and we could see if we can squeeze you into to that session. We try to keep the class sizes pretty small so that we can give the level of attention that everybody wants. But I think that's at 12 people, and so we've exceeded 12 at this point. But again, maybe we can squeeze 1 or 2 more in. So good question. Oh my gosh, that went fast, guys. Well, I thank you for hanging there. I know I didn't get to all the questions, so we will follow up with you in the follow-up email and answer your questions directly. So thanks for tuning in to this Getting Started with OEE webinar. We kind of do a lightning run through, and hopefully this helps introduce you to more of the resources that we have for you, both live with folks online, with design consultation calls. So as I said several times, if you have a question, feel free to reach out to support. We can get that scheduled. Or if you use our existing materials, such as the user manual, the videos, or the step-by-step tutorial. So thanks again for tuning in. And like I said, you'll get a follow-up email from us with some of these resources, and we'll do our best to answer your questions. Have a great day, and talk to you soon.